Good morning, everyone. In today's lecture, we will begin our formal study of artificial intelligence. Now, this is a term you've undoubtedly heard, but our objective is to move beyond the popular headlines and understand it as a foundational technology that is fundamentally shaping our modern world. Think of it less as a single invention and more as a systematic discipline, one that's having an impact on par with the advent of electricity or the internet. So let's begin by establishing a clear, academic framework for what AI is, how it functions, and why its emergence is so critical at this moment in history.
Here is the roadmap for our discussion. First, we'll examine the historical context from which AI has emerged. Then, we will establish a precise academic definition to guide our study. From there, we'll analyze the core components that constitute an AI system. We will then delve into the fundamental mechanisms of how machines learn. And finally, we will situate all of this within the modern world, exploring its applications and its economic significance.
So let us begin with our first topic. It's important to understand that artificial intelligence is not a sudden development. Rather, it represents the current frontier in a long-standing human endeavor, the quest to augment our problem-solving capabilities. If we look at this evolution, we can identify three distinct eras. For millennia, we operated in the manual era, where every calculation and every decision required direct human intellect and labor. With the advent of the computer, we entered the digital era. This was revolutionary, of course, but these early systems were fundamentally rule-based. They could execute complex instructions with incredible speed, but they could only do what they were explicitly programmed to do. Today, we are in the intelligent era. The defining characteristic of this era is the emergence of systems that are data-driven and adaptive. They don't just follow pre-programmed rules, they learn from data to create their own. This transition from static programming to dynamic learning is the paradigm shift at the heart of AI. This progression leads us to a critical question. Why has this explosion in AI capability happened now? The answer lies in the convergence of several key factors. We now operate in an environment of unprecedented data volume, what we call big data. Simultaneously, global competition is more intense than ever, and the pace of change creates constant uncertainty. In this complex environment, the ability to make sense of vast amounts of data to make better, faster decisions is no longer a luxury. It has become a strategic imperative for survival. AI provides the tools to meet that imperative. Having established the context, let us now turn to a precise definition. A great deal of misconception surrounds the term AI, often fueled by science fiction. For our purposes, academic clarity is paramount. We must be able to distinguish what AI is, and, just as importantly, what it is not. Formally, artificial intelligence is a systematic approach that enables machines to simulate aspects of human intelligence. The word simulate here is crucial. We are not talking about replicating consciousness or sentience. We are talking about simulating specific cognitive functions. These include learning from past data, much as we learn from experience, reasoning to draw logical conclusions, recognizing complex patterns in data that a human might miss, and ultimately using these capabilities to support human decision-making. And this is the fundamental distinction that separates AI from traditional software. A traditional computer program operates on explicit, hard-coded rules. A spreadsheet, for instance, performs calculations exactly as it was programmed to. Its performance is fixed. An artificial intelligence system, on the other hand, learns from data to create its own rules. And because it can continue to learn from new data, its performance is not fixed. It can actually improve over time. This adaptive capability is what makes AI so powerful. With a clear definition in hand, we can now deconstruct the intelligent machine. Let's examine the essential building blocks, the core components required to build and operate a functional AI system. We can conceptualize any AI system as resting on 5 pillars. First is data. This is the raw material, the fuel, without which no learning can occur. Second, we have algorithms, which are the sophisticated learning mechanisms, the engines that process the data. Third, the output of this process is a model. This is the tangible result, the distilled knowledge learned from the data. Fourth, you need computation, the immense processing power required to run these complex algorithms on vast data sets. And finally, and this is critically important, you need human oversight. This is the guiding hand that ensures the system is used ethically, responsibly, and in an accountable manner. All 5 are indispensable. This brings us directly to the engine of the system, the learning process itself. This is the domain of a subfield of AI known as machine learning, and it is the key to understanding how these systems actually work. This raises the central question at the heart of the field. How is it possible for a machine to learn to perform a task without a human programmer writing explicit instructions for every single possible contingency?
The answer, and this is a key concept to grasp, is that this learning is statistical, not conscious. An AI system does not understand a concept in the human sense. Instead, it uses powerful algorithms to identify subtle mathematical patterns and correlations within massive amounts of historical data. It then uses the statistical model of the past to generate probabilistic predictions about new, unseen data.
This is achieved through a process we can call the learning loop. First, the system is trained on a large data set. It then makes a prediction. It receives feedback on that prediction, typically by comparing its output to a known correct answer, and it calculates its error. Then, it adjusts its internal mathematical model to reduce that error. This process is repeated, iterated, millions or even billions of times, with each iteration refining the model and improving its predictive accuracy. So, having explored the theoretical underpinnings, we will now conclude by examining AI's role in the modern world. We will look at the different types of AI that exist, their practical applications, and their significant economic impact. It is essential to understand that the AI we interact with today exists on a spectrum. The dominant, and currently only existing form, is what we call narrow AI, or ANI. These are systems designed and trained to master one specific task exceptionally well. The concepts of general AI, or AGI, a machine with human-level cognitive abilities, and super AI, or ASI, an intellect that surpasses human intelligence, remain, for now, conceptual and future-oriented ideas. Our world is being reshaped by narrow AI. To make this concrete, let's consider a prime example of narrow AI in action: computer vision. This is an entire field dedicated to a single, narrow task, enabling machines to derive meaningful information from digital images and videos. The system isn't intelligent in a general sense, but it can see and interpret visual data with a speed and accuracy far beyond human capability. The real-world applications of this are profound. In industrial quality management, for example, computer vision systems can detect microscopic defects on a high-speed production line that would be invisible to a human inspector. They can automate the sorting and grading of agricultural products, monitor a construction site to ensure workers are complying with safety regulations, and in doing so, dramatically enhance operational performance and consistency. And this impact is not isolated to manufacturing. AI is becoming a foundational economic layer, driving value across nearly every sector. In business operations, it enhances efficiency. In finance, it enables more sophisticated risk analysis. In healthcare, it aids in diagnostics. In education, it allows for personalized learning paths. And across the board, it's automating certain tasks, reshaping the nature of employment. This brings us to a crucial conclusion regarding AI's role in the economy. Its adoption is no longer about gaining a minor competitive edge. For entities of all sizes, from individuals and startups to the largest global corporations, integrating AI is becoming a matter of survival. It is the key to remaining adaptive and competitive in an economy defined by rapid, data-driven change. And so I will leave you with a final question for your consideration. As these specialized, narrow AI systems become increasingly proficient at analytical and procedural tasks, tasks that once defined many human jobs, what are the uniquely human skills such as creativity, complex problem-solving, and ethical reasoning that we must now cultivate to thrive alongside these powerful new technologies? That concludes our lecture. Thank you.